Today we're going to talk about understanding the EV zone. And to start with, we're going to describe some things, and this is going to be a little more audio than it is actual video. But let's take a look at the yellow diagonal that is running, that separates the strike zone. On that diagonal, we have a middle, down and in, up and away. Those three locations. Each time the ball moves closer to the batter, the speed is increased, and it's not really increased. It's increased effectively because he has to get the bat head further out in front in order to make 100% on-time contact. So this diagonal line is really a neutral line. So as the ball gets closer to him, for example, let's just say that we're talking about a 90-mile-an-hour fastball right down central in the black. Okay, as the ball goes to the down and in location, it's going to move over 6 inches, and it's going to move down 8 inches. So each time it moves closer, it gets faster. But because it's going downward more, it counteracts each other. The two effects of speed, as it pertains to location, has just changed. But it's changed in a way where they cancel each other out. Same thing up and away. When the ball's elevated, when it's higher, it's going to gain a little bit of speed. But when it's moving away from you, it's going to lose a little bit of speed. And because it's up and away from this right-handed batter, we're talking about another case of counteracting. So down and in, middle, and up and away are all the same reactionary time. Now, the way it works is if this ball moves over 6 inches, the barrel of the bat doesn't move over 6 inches. The barrel of the bat is creating an arc. And when it's creating an arc, it has to go 18 inches further out in front in order to make contact. It doesn't just make the contact over here. It has to get way out in front in order to make that contact. So when this pitch is up and in, for example, he has to hit it way out in front in order to be 100% on time. So let's take a look at that in real life, and we'll try to show something, a measurement that will actually help this point of contact. Okay, so this is an inside pitch, and he's hitting the ball definitely well out in front of home plate. Okay, and again, he's not exactly 100% extended here, but he's pretty close. His lead arm is extended. He's released his backside, so he's pretty close to being 100% extended. But the reality is that's the place where he's 100% extended. So not necessarily does that mean that he's late, but this contact point could have been as far out front as right there. Just to kind of illustrate the point. So let's go back and do a little measuring just so that we can see what we're dealing with here. I'm going to measure the barrel of the bat, or the length of the bat. And we have just about a 32-inch bat, and I think that's what he was swinging that day. So that's a 32-inch span right there. So we know that distance. When he makes contact out here, if he were to make contact here, or even all the way back here, this ball is probably going to go foul if he hits it here. But the difference between, let's go back to this contact point, and we'll mark that with a little 0. And we'll go to this contact point and mark that with a little 0. And then let's do a measurement that shows us the difference between those two. We're talking about almost 43.5 inches or so. So that's a huge span. That's a huge difference in reach from this pitch way back here to this pitch way out here. That's virtually 4 feet of space. Three clicks and 4 feet. So every time this click happens, it's a little over a foot. If we take this, it's just about a foot every time we have a click in the action. But the point of this is to show that when you look at the strike zone from a one-dimensional standpoint, like a flat surface, it's really hard to understand it because it really isn't flat. It really is three-dimensional. And so for him to make contact out here is very different than him making contact here or here or even all the way back here. Each one of those are vastly different. So the speed of the pitch and the location of the pitch is going to determine whether he can get to this really good hitting position and get the barrel to this point in time at exactly the right time. And that's a difficult thing to try to pull off. To go back to our example here, this +6 area, he's going to have to hit the ball way out in front. That's kind of like where he was at in our last example. The +3 would be out in front, but not quite as far out in front. And this one would be not out in front at all. It would be a lot less because it's losing as it goes down. It's losing reactionary time because the hitter has a different reach at each one of these points. And as the ball goes to the outside part of the plate, now he's going to have to hit it even further back in order to be able to make contact. So let's just use 3 points. A couple of feet out in front of home plate here, a foot out in front of home plate, and then equal to the front edge of home plate on the down and in location. And these are just estimations, just to give you kind of an idea of depth. And then as it moves here, it goes 6 inches behind the front edge of home plate in either one of these two locations, and it goes to, let's just say, the back edge of home plate when it gets to this +6 or -6. So that hopefully will help to understand why it is that each of these locations makes a dramatic change in the reaction time of the pitch, because for every 6 inches the ball moves in, it gains 18 inches of arc of the bat, because he has to get that much further out in front. He doesn't just lose 6 inches. He is losing 18 inches. He has to get the bat 18 inches further out in front. So that's why there's such a dramatic difference between those two things. So if we look at this fastball on the outside part of the plate, and it were 90 miles an hour, it really would equal about 84 or 85, somewhere in that range. And the reason for that is because he has a longer amount of time to be able to make contact, because his contact point is so much further back. It's like the airplane that is taking off from the same place, but in one case it flies to Santa Barbara, in another case it flies the same speed, it flies to San Francisco. Even though the plane's going the same speed, it's going to get to those two different cities at very different times. And that's what's happening here, is the bat has to get to two very different places on this away fastball versus this inside fastball. So that's why the speed changes so dramatically when you start thinking in terms of where the ultimate contact point is in relation to the location of the pitch.